Hi, I'm Russ with ESBService.com, and today I want to talk to you about buck boosters and surge protectors for your tanning bed. I get a question a lot as far as, do I even need a buck booster? Well, the question is, what is your receptacle voltage? And that will help you to determine if you do or do not need a buck booster transformer. There are two types of voltages that ESB beds run on, either 120 volts or 240 volts. A lot of times this is referred to as 110 and 220. On a 110 volt bed, especially older ESB tanning beds, meaning before mid-2000s, the 110 volt bed would be specified to run on 110 to 120 volts, no lower and no higher than that. For the 220 beds, especially the older beds again before 2005, the 220 beds would be specified to run on receptacle voltage of 220 to 230 volts. Again, no lower than that and no higher than that. So if you have a 110 volt bed and you check your receptacle and your receptacle says 115, you're just fine. If it's down as low as 110 or up as high as 120, you're just fine. You would only need a buck booster if you're so far out of that range and you need to put it into that range. For instance, if you had 135 volts at your receptacle. A buck booster has two functions, one or the other, depending on how it's wired. Either it's going to be a bucking transformer or it's going to be a boosting transformer. Bucking means it's going to drop it, boosting means it's going to increase it. So in my example of 135 volts, you would need a bucking transformer, which would typically drop the voltage 17 volts. If you say you were 17 volts too low, then you would need, or roughly, you would need a boosting transformer. They both start out the same. A buck booster starts out the same. It's either turned into a bucker or a booster, depending on how it's wired up. But that is what determines if you need the transformer. Basically, if your receptacle voltage is too far outside of that specified range. Now, this is a lot more common on the 220 side because your voltage on 220, if you actually run a voltmeter on your receptacle, a lot of times you would find that your voltage is closer to 245 or 250, say. And this is where you would need the buck booster for sure to drop that receptacle voltage from about 240 down into the acceptable range for your tanning bed. Now, since 2005, ESB has incorporated some more modern electronics that don't require you to use buck boosters. So for almost the last 10 years, they have been pretty much a thing of the past. But I know a lot of people out there have older tanning beds, and especially if you're having electrical problems, that might help you to determine the root cause of that. If you have receptacle voltage that is simply too high or too low for what your bed is specified for. So again, that's what determines if you need a buck booster or not. Whether your receptacle voltage is within the spec or not and needs to be corrected. You do not want to use a buck booster if your receptacle voltage is just fine for your bed, because then it's going to throw it out of the range that it needs to be in. So the next question that comes up is, well, what about a surge protector? Well, a surge protector is there only to protect the circuitry in the case of, say, a swell in the voltage or a spike in the voltage. The problem that I see with that is the fact that most surge protectors that are available are only rated for 15 amps. And everything that the tanning bed is plugged into, the whole electrical service needs to all be spec'd for 20 amps. So if you find a 20 amp surge protector, perhaps online, I know it's hard to find in a local hardware store, but if you find one online, perhaps that would be a good idea, but usually they're quite expensive. So my best recommendation is, instead of using a surge protector, just simply take and unplug the bed from the power source when you're not using it. And that's the best protection from voltage swings, from spikes and surges, and even solar flares. If it's unplugged from the source, then the internal components can't be affected by it. And there's a lot of other things that surge protectors won't necessarily protect your bed against. So again, that's my best recommendation. Just simply leave the bed when it's not plugged in, and make sure that when it is plugged in, it's plugged in to the appropriate power source and you do have the correct voltage. If you do not have the correct voltage, then you want to get that rectified with the proper buck booster transformer. So, since we're talking about buck boosters, I just wanted to add one thing. If you're wondering how to actually wire the buck booster itself, there are two different wiring schemes. One for bucking and the other is for boosting. Now, I don't have a buck booster transformer with me here, but basically a buck booster is going to be just a big electrical box, and there's two cords coming out of it. One is a plug and the other is a receptacle. The plug is what goes into your wall outlet, and the receptacle is what your bed plugs into. Now, when you open up the buck booster itself, you open up the case, there's going to be a bunch of wires in there. There's going to be 8 wires. Now, this is the actual wiring configuration that you will see inside the buck booster. If you are needing a bucking transformer, meaning that you're dropping the voltage down, from your plug, you're going to have a green, white, and a black. And the green is going to go to the case ground on the plug and the receptacle, as shown in the diagram here. The white from your plug is going to go to the X1 wire, and that's it. The black from your plug and from your receptacle are both going to terminate on the H4. From your receptacle, the white wire is going to connect to the X4 and H1. The H3 and the H2 will be connected together, and the X3 and X2 will be connected together. And this will provide you with the bucking configuration for your transformer. If you have, basically whatever you have here is going to be dropped 17 volts coming out there. And I would recommend that you check the receptacle voltage before plugging the buck booster into it, and then also before plugging the bed into the receptacle of the buck booster, I would recommend that you check that voltage as well first. Now, if you needed a boosting transformer, meaning that you would need to increase the voltage roughly 17 volts, you still have your receptacle and your plug, but they're going to be wired a little different. In this case, the green from the receptacle and plug still are both connected to your case ground. And your white from your receptacle is still plugged into the it's not still, now it's plugged into X4 instead of X1. And then the black for both the plug and the receptacle are going to go to the H1 termination. The X2 and X3 are connected together just like in the other configuration, as well as the H2 and the H3. But the white, the neutral on the plug coming out of the buck booster, is going to be connected to H1 and H4. And of course, being that this is a high voltage and high amperage application, I would recommend that you ensure that you have very good solid connections and that you're only using the proper connections for the gauge wire.